So our speaker today is Rick Bohan. Rick is the Vice President of Sustainability for the Portland Cement Association. He's been working 30 years in the cement industry and research and technology, and he leads the Portland Cement Association's efforts on producing a roadmap to decarbonization of the concrete industry by 2050. And this is a particular current interest in California because there is legislation regulating the carbon in cement, which is the glue, as Rick will talk about. So this is a topic of legislative interest for the last 4 years in California, for better or for worse. So with that, let me hand it up. Rick has a little bit of a weak Wi-Fi connection, I believe, so he's going to keep his video off until we get to questions. So with that, let me hand it off to Rick.
Hey, thanks so much. I really appreciate it. You guys can hear me okay?
Yes.
Yeah.
All right, terrific. Hey, listen, I really appreciate the invitation. Big thank you to the entire staff, Davis. So let's get right into it. There's a lot to cover. Next slide, please. Okay. You know, it seems like everybody is doing some kind of a roadmap. We are not alone. The Portland Cement Association, we came out with a roadmap a couple weeks ago. GCCA is the Global Cement and Concrete Association. They too came out with the roadmap. They have 9 regions throughout the world. CEM Bureau, the European Cement Association, they came out with one. VDZ is the German Cement Association. Our friends up north in Canada are coming out with one shortly. And I should point out that ours, we collaborate, we cooperate, we coordinate with all these organizations. And we were really fortunate enough to have a lot of input on our roadmap from NRMCA, the National Ready Mix Concrete Association, as well as MIT's Concrete Sustainability Hub. PCA and NRMCA both co-sponsor that organization. So that all these folks, and there's a lot of similarities with these roadmaps, but all these folks communicate on an ongoing basis. Next slide, please. The entire roadmap can be found at our website at cement.org. It is a very comprehensive 68-page document with FAQs and glossaries and a lot of good information. And I know I've got time today to kind of walk you through this, but I would encourage you to go to the website and you can either view it online or download it if you like. We're also going to be transitioning that to an electronic format, but we're very transparent about it and we're very proud of what we've done. So, you know, keep in mind that if you have detailed questions, you can always go there. Next slide, please. Okay, look, I'm going to admit I've got a guilty pleasure. I love F1 racing, and that has nothing to do with cement and concrete, but here's my point. I've got 3 big themes I'd like to introduce to you before we even get into the roadmap. So as an F1 race enthusiast, I can tell you that there is heat reflective gold tape, not just gold color. It actually has gold on the tape. It's expensive. So a couple of weeks ago, I went online, and if I wanted to buy a 2-foot wide roll, 150 foot long, it's about $3,200. That's expensive. So here's my point. If I was going to buy that, I would think long and hard about where I bought it, how much of it I bought, why I bought it, where I would use it, how much of it I would use, and maybe just as importantly, who would I have to apply it? And I say this all to give you the first theme, and that is we as a society, if we're going to address global warming, we have to be intentional about it. So when you think intentionality, think of this gold foil tape if you had to pay for it coming out of your pocket. So the first big concept is intentionality. Next slide, please. And here's the next big thematic concept I want to get across. I'm a big believer in optimization. And to me, optimization has two basic components. I think everybody's familiar with the bell curve. When my kids ask me, hey, how did I get through college? I like to say, yeah, standard deviation. But here's the point. When we look at optimization, I think there are two key points here. One is shifting the curve, taking that bell curve and shifting it to the right. And by that, what I mean is that, look, if you look at the traditional bell curve, on the right-hand side, you have star performers, the really innovative crowd, the folks that are truly pushing the envelope. Think Elon Musk and the guys that, at Apple and Google and wherever. They are always going to be pushing the envelope. And that right-hand tail is always going to be pushed out further. And then you've got the core category, the quote-unquote average. And then finally, you have the other tail end where you have slow adopters. And I would say that in a lot of cases, the slow adopters, in many cases, they're slow adopters through no fault of their own, okay? So don't confuse slow adopters with poor performers, because when it comes to the marketplace, poor performers do not last. Now, when I say shifting the curve, what I mean is that optimization in our industry and across the board means we've got to shift the curve such that the slow adopters get pushed into that category of core performers. We've got to shift that curve to make sure that the core performers are actually where the star adopters are today. But optimization isn't just shifting the curve, it's also shaping the curve. So ideally, what I'd like to see is I'd like to see a very narrow difference between the star performers and the slow adopters. I would like to see an industry that across the board is very innovative and is really pushing the envelope. Next slide, please. So that was thematic concept number 2, call it. Okay, so optimization, we talked about intentionality. Here's the big theme, the last theme I'd like to kick off with. Society needs concrete. Now, like it or not, every single construction project worldwide uses some amount of concrete. I don't care if you're building a log cabin in Idaho or a skyscraper in Toronto, you're going to use some concrete. And it is truly the universal building material, because even if you're using mass timber, steel, composite, whatever, for the superstructure of the building, you'll still use some amount of concrete. And concrete needs society. So as I talk about this roadmap, one of the things I want to get across to people is that we can't do this on our own. And by we, I mean the cement industry, the concrete industry. We need everybody who looks, everybody who touches our entire value chain to help us out. That's really critical. So society needs concrete and concrete needs society. Next slide, please. So for those of you that might not be familiar with cement and or concrete, let me give you a distinction here. So the analogy we like to use is that cement is to concrete as flour is to cake. So if you're not an engineer or an architect, or you're not involved with materials, that's always a good analogy to keep in mind. Cement is to concrete as flour is to cake. So I represent the cement industry, but cement is only one component of concrete. So you walk on a concrete sidewalk. You probably park your car or your, whatever in a concrete parking garage. If you're traveling anywhere on an aircraft, you're landing on a concrete runway, all right? So concrete is composed of cement, some type of aggregate, usually sand and gravel and maybe others. And there's water as well. And then there's always a certain amount of air. And I don't want to get any more detailed than that, but just again, to distinguish between cement and concrete. Next slide, please. Okay, so we're trying to reach our target is carbon neutrality by the year 2050 throughout our entire value chain. Now, why 2050? Well, we could get there sooner, and I'll talk about how we can do that. But why the value chain? Because we in the cement industry can't do it on our own. And as a matter of fact, even the concrete industry can't do it on their own. We have to have everybody involved in the value chain help us out and help us reach that goal. So our value chain starts off with an intermediate product called clinker. I'll talk about that in a minute. But that's not our final product. That ends up, that's the primary ingredient in cement, but that's not the final product. And of course, cement is used in concrete, which is still not the final product. Really, our final product is the built environment. It's buildings, it's bridges, it's tunnels, it's pavements, it's everything. And then we'll also talk about the use of concrete as a carbon sink. So this is our value chain, those 5 links, we call it the 5C. And that's a very similar approach that SEM Bureau and others have taken to carbon neutrality as well. Next slide, please. So where does this CO2 come from? All right, well, we have 2 sources. The top equation, and by the way, this is the only chemistry I'm going to get into. The top equation is what we call the chemical fact of life. Making cement starts off with transforming calcium carbonate or limestone into lime and carbon dioxide. That is the very initial reaction we need. And without that reaction, we don't make cement, period. Now that reaction requires a material temperature on the order of 2,800 degrees Fahrenheit. Let's put that in perspective. The average consumer's oven or stove reaches maybe 500 degrees Fahrenheit. Surface temperature of the sun is about 10,000 degrees Fahrenheit. So we need material temperatures of about 2,800 degrees Fahrenheit. That chemical fact of life represents just over 60% of the CO2 that our industry puts out. Now the bottom equation, if we need 2,800 degrees Fahrenheit, or for those of you in the metric crowd, about 1,500 C, if we need those kind of temperatures, at least today in 2021, really the only reliable way to reach them is through combustion. So think back to high school chemistry. Combustion is, rapid oxidation, primarily through carbon. And most of our materials that we're burning are coal and pet coke. Yes, you can burn hydrocarbons like methane and natural gas, and of course, other complex hydrocarbons. But the temperatures we need require combustion, and that represents, roughly speaking, just under 40% of our CO2 footprint. So if you look at the US cement industry, we account for about 1.25% of the equivalent CO2 emissions in the US, and just under 0.18, just under 0.2% globally. And by the way, CO2 equivalent, so the vast majority of our greenhouse gas emissions are almost entirely CO2, but there are some methane emissions that get included in there. Next slide, please. Now look, don't take, and I know there's a lot of students, so don't ever take anybody's word for it. If you really want to do those numbers on your own and figure out the percentage, you can do that, because the cement industry, by law, we have to report our CO2 emissions. And you can go to the EPA's flight database. It's publicly available. The acronym is Facility Level Individual Greenhouse something or other, who knows. But anyway, you can actually go in there for every industry that has to report GHG emissions, and you can screen and filter. And I just checked again yesterday. So if you do that for the cement industry, we have about 92 operating plants in the US, and they produce roughly 66 million metric tons of CO2 equivalent. So that becomes your numerator for that fraction. Next slide, please. And then for your denominator, you need the cement production. And by the way, these numbers are all in thousands of metric tons. So at the very top, you see the US in 2020, the most recent year we have data for, produced 90 million metric tons of cement. Now, in comparison, China is at whatever that is, 2.2, is that billion, 2.2 billion. They are the world's leading supplier of Portland, or consumer supplier of cement. They're followed second place by India, and then third place, just barely edging us out, is Vietnam. And then, by the way, this data is produced by the US Geologic Survey, so you can actually go on their website. So that gives you your denominator, and that's why I say we represent for the US about 1.25% of all GHG emissions. And that's not to dismiss 1.25, because it's still a healthy number. It's still a healthy set of emissions. Next slide, please. Okay, so what can we do to reduce that number? Well, firstly, we can start at the cement plant with this product, this intermediate product called clinker. Now, by and large, you know, hopefully you've probably seen fresh concrete, and maybe if you're like a lot of people, you're tempted to put your handprints in the concrete. Please don't do that. Fresh concrete is a very caustic material. It has a pH even more aggressive than lye and or Drano that you would use. So don't ever do that. But look, the reason concrete is plastic for an hour or so is because we add small amounts of gypsum to it. So, small amounts of gypsum to the clinker. So what can we do with the clinker? And this goes to the point about reducing, you know, the amount of CO2 coming from that chemical fact of life. Well, what we could do is take materials that don't have CO2 attached to that calcium. And that includes things like slag and other materials that have calcium that have already been processed, some byproduct materials. Now, our limit there is just the availability of those materials. Well, so that helps us on the process, on the chemical fact of life. On the combustion side, we can do things like efficiency gains. We're really pushing the edge, though, because our thermodynamic efficiency at a cement plant, roughly speaking, is about 80%. So we can get marginal increases of 1 or 2%. We're not going to see 10%. We're certainly never going to hit 100%. Obviously, I went, had a course in thermo. Okay, some other things we can do, though. We can switch to different fuels. There are a lot of materials that right now are being diverted to landfills. And because of the flame temperatures that we use, we can dispose of those in a pretty environmentally friendly manner. And obviously, we're not just reporting CO2 emissions. We are governed by the EPA. So every cement plant has to follow very strict emission limitations. Ultimately, we can look at transformative fuels. So in particular, hydrogen. Hydrogen would really be a game changer, right? Just across the board. It has more fuel value than just about anything else out there. And obviously, no CO2 that goes with it. Plasma arc technology, somewhere down the road, I think that's a foreseeable thing. The drawback there is we need something 24/7. We need electrodes and anodes and cathodes that can last not a few hundred hours, but I mean, tens of thousands of hours. We could also look at using pure oxygen for combustion. So these are all things that would really transform the industry and, of course, reduce the CO2 from combustion. So that's that 40% of CO2. And then finally, look, that'll get us part of the way there, but ultimately we're going to have to use carbon capture. So let's talk carbon capture. Next slide, please. Let's go to the next one. There we go. Thank you. So let's talk carbon capture, because carbon capture is, it is huge. And what you're looking at here, this is Chevron's Gorgon plant in Australia. It's designed to capture 1 million tons of CO2. Now, the cement industry, about half of our plants in the US produce more than 1 million tons of cement annually, and about half of them produce less than 1 million tons of CO2 annually. That CO2, for every ton of CO2, for every ton of cement, we produce, we're talking about maybe 0.9 tons of CO2. Next slide, please. So this is the size and scale of a facility that a lot of our plants might be looking at in terms of carbon capture. You're really looking at something almost of the scale of the Manhattan Project. And it might be difficult to see, but you can see the road, and on either side of the road, if you look closely, and I'll be able to share this after the presentation, if you look closely, you'll see some of these construction trailers. This is a huge undertaking. Right now, there is no at-scale CCUS in the cement industry anywhere in the world. We don't know that we can scale it up. Now, I think the technology, I think we're going to be able to do it. We won't do it in 6 months, but I think we can do it in 6 years. That's my prediction. Going to take a lot of research, but and some other things too. But CCUS is an integral part of our roadmap. Next slide, please. Well, if we're going to do that, though, then the question becomes, well, what do you do with the CO2? And folks, I got to tell you, we have a real infrastructure problem. So we can't just dump the CO2, underground. Not every plant has the geology necessary for that. So in some cases, we're going to need pipeline capacity to ship that CO2 somewhere where it can be safely and permanently sequestered. And by the way, on the pipeline issue, the other thing is, if we want to go to a hydrogen economy for industry, I hate to say this, you're going to need pipeline capacity, because right now, on-site hydrogen generation, it's at least 2 orders of magnitude below what we would need to operate, in the cement industry, in the glass industry, in any of these industries. Next slide, please. And this gets to the point about energy. So look, part of the challenge we're dealing with today is that we need a robust and a reliable electric grid. And in some parts of the country, that does not exist. Every single industrial user I'm aware of is desperate to start transitioning to renewable energy. To do that, we have to have grid capacity. Next slide, please. Okay, so I'm a big proponent of clean energy, in particular wind power. Well, like I said, society needs concrete. Here's a great example. You want wind power. When you see those windmills, keep in mind that underneath that windmill, there's a concrete foundation. In many cases, it's about 15 meters in diameter. So what, 45 some odd feet, and essentially 5 to 7 feet deep. They are huge. As a matter of fact, wind turbine bases, windmill bases represent one of the most single intensive uses of concrete that there is. Next slide, please. Sorry for the delay. I'm still waiting. There we go. Thank you. So those are all things we can do on the clinker side. So what can we do once we make the cement? So look, we could reduce the amount of clinker. And for every amount of clinker we reduce, we've got to replace it with something. And there are materials out there we can replace it with. Again, slag is a great material. In some cases, fly ash. Now, fly ash is a byproduct of the coal power industry, a coal energy industry, rather. And even if tomorrow every single coal plant was shuttered, there is so much fly ash that has been landfilled, impounded, and stored over many, many decades that even if only just a few percentage of it was worthwhile to go back and process, there's plenty of that material to incorporate in both cement and concrete. Other things we can do. Shifting from prescriptive specifications to performance specifications. So a prescriptive specification is essentially a recipe. It's a cookbook recipe. Use X percent of this, Y percent of that, and so forth. But you know, the more efficient way is to actually look at what do you want at the end, and that's performance. So in some cases, you want high strength concrete. In other cases, you just want a really durable material. The example I like to use is my sidewalk outside of my house in Chicago. That sidewalk has the same strength as a concrete column in a high rise. I know that sounds crazy, but it's true. My sidewalk does not need that kind of strength. On the other hand, it needs far better durability than that concrete column that's never going to be exposed to de-icer salts and other chemicals and freezing and thawing. So, you know, this is part of the issue we deal with. Anyway, so switching from prescriptive to performance specifications, here's another one. A real simple thing we can do is Portland limestone cements. So you can take limestone and add it to cement. And right now we're allowed to do that. And by doing that, we can cut our CO2 footprint of cement by 10% right off the bat. 10%. There are still some states and some state Department of Transportations that do not allow that. And the difference between a Portland limestone cement and another cement is essentially the difference between, the analogy I use, the difference between Coke and Coke Zero. You're going to get the same taste. In the case of the cements, you're going to get the same performance. Why they're not doing that is beyond me, and that's where we need society's help. New cements. I think there are new cements on the horizon. They are years and decades away, but certainly as a material scientist, I know they're coming. And then finally, how we get the material, how we get concrete to the job site, whether it's in a concrete mixer with the revolving drum that you probably see, whether it's a cement bulk carrier. There is a real movement to shift away from diesel and shift towards zero emission. And by the way, that's across the board. I deal with rail carriers who are now trying to transition their fleets from diesel electric locomotives to all electric locomotives. That takes time. That's not going to happen in 6 months or 6 years because they've got a fleet of, thousands of locomotives and they have a huge, stranded investment. But that is something that they're doing today, that they're starting to, transition this over. It'll accelerate, but again, it takes time. So those are some things we can do to optimize cement. Next slide, please. Okay, and we talked about the difference between cement and concrete. So just a reminder, cement ends up in concrete, flowers to cake, cement is to concrete. Next slide. So what can we do on the concrete side? Well, look, there's a lot we can do because those same materials like slag, fly ash, silica fume, these are materials that can be used in concrete as well. We can reduce the energy consumption of concrete plants by switching to renewable energy. There are some breakthrough technologies that are out there, but one of the things I want to focus on is actually optimizing concrete itself, optimizing the mix design. So if you could go to the next slide. So look, when we talk about mixed designs, I've already talked about this idea of transitioning away from a cookbook type mentality to performance-based specifications. That's not anything new, but we need people to get more innovative in accepting that. And it's not like we're asking people to take a risk. These specifications have been around for quite some time, not just on the material side, but also on the testing side. And you'll see me here when we get into the Q&A session. Look, I'm an old guy with white hair, okay? I'm getting close to retirement. One of the frustrating things I have is that I do my darndest to keep up to date with the latest and greatest on research. And one of the reasons why is because PCA, we fund research fellowships. So I get a chance to deal with the best and brightest. And I'm dating myself, but I'm actually now at the point where I'm seeing students who got their PhD from our research fellowships who are now department heads. Look, the point is, there are a lot of architects, engineers, building owners. There's a lot of people out there that are set in their ways. They learned one way and they have institutional inertia. It's not so much that they're risk averse, it's just they haven't progressed from whenever they went to whatever class it was or whatever newspaper they read. So a big part of our roadmap is to ask people, look, we want to incentivize innovation. We want to incentivize innovation. We want people to be in that star performer category. You know, I know Elon Musk is a multi-bazillionaire, but Elon Musk isn't the only guy out there who's innovative. There's a lot of people out there, and there's a lot of people in the room I'm looking at who are also innovative. So we want to incentivize that. And to do that, there's a lot of solutions that we're trying to make people aware of and remind them of. Portland limestone cements is just one example. Do you know that until this past year, Caltrans didn't even consider it. They wanted to do their own testing, even though it had been used it's been used since the 1960s in France. I mean, look, I don't get it. And then here's the other thing on the bottom that I want to key in on. Artificial intelligence, using the right mix with the right materials to get the right application for the right performance. You know, there are a lot of things off the shelf available today. They don't need, and by the way, these aren't outrageously expensive. They're available, you know, to the kid that just got their architecture license or their engineering license, you know, to the 2 and 3 person design shop. These are available today, and we're trying to highlight them. Next slide, please. Okay, so we've talked about clinker at the cement plant. We've talked about cement and concrete. Now we get to construction. And again, this is part of the value chain. So you look at the built environment. There are 4 phases. There's a design phase, the actual construction phase, the use phase, and then finally the end of life. Next slide. So in the design phase, again, there are a lot of things designers could take advantage of today. One of the big ones that I would love to see incorporated universally is augmented reality. You know, when you want to buy a house, let's say 1,000 miles away, nowadays, you don't have to get on an airplane. You can put on a pair of 3D, virtual glasses, and you can actually have a virtual walkthrough. And now we're getting to the point where you can get the tactile response of what the finishes look like. You can increase the lighting or decrease the lighting to see what it looks like throughout the day and throughout the night. That's the kind of, and people laugh when I say this, but I got to tell you, I really think that augmented reality potentially will make change orders and punch lists a thing of the past. I really do. I think I'll see that within the next 10 years. I know on the industrial level, when we're building industrial facilities, you wouldn't do this without augmented reality, without actually walking through the entire site before it even gets down to an electronic drawing file. Next slide, please. So that's in the design phase. You know, you get to the construction phase. I love this picture because I love kids too, but look, you go to most construction sites and essentially this is what you see. I don't mean a bunch of little kids with Legos in front of them or Duplos in front of them. But what you see on most construction sites is this chaotic pandemonium where nobody has really given any thought to what goes where. You have different trades that they're not sure when they're supposed to be, where they're supposed to be. I mean, it really is the definition of chaos. And I use this picture to encapsulate, to summarize that. There is no need for that. Construction sites, when I go to Europe, they're almost sterile. It is night and day. Now, to be clear, if you go to a major industrial project, they're much better, but there's still a long way we can go. And if you think about the amount of time and effort and carbon that's wasted when you go through that kind of a process, it's a lot. Next slide, please. Great article, I'll send you the link, but these are some of the things that are, again, available today. These are not exorbitantly or prohibitively expensive. So number 4 is my big one, immersive reality. I'm big on that. 3D printing, I'll point out, yeah, I think that has a really bright future for concrete, especially because it's zero waste. We could talk about, I could spend hours talking about that, but again, I'll send a link to that article. Just keep in mind, available today. Next slide, please. Okay, when we get to the use phase, now, on the left-hand side, that's the Empire State Building, and believe it or not, the Empire State Building within the next year or two will be 100 years old. Think about it. People fixate on the embodied carbon of concrete, of steel, whatever. On the other hand, what I'd like to do is put that in perspective. Think about all the energy consumed in the Empire State Building between the elevators, the escalators, the boilers, the chillers, the air handling equipment, the workstations, the display screens, the power outlets, moving, pumping water up and down. And folks, all that energy for a building that's 100 years old, that dwarfs that. I mean, the impact that has in comparison to the actual building materials is huge. So I'm not against people pointing to the embodied carbon of materials, but do that in the context of a structure that is designed to last for decades, okay? Next slide, please. And by the way, the US General Services Administration, they're keen on this. They get it. We meet with our high performance building team. And look, if you design for long life, if you know that building's going to be around for decades, you get lower energy use, lower water use. You can make it more economical to operate the building. And oh, by the way, you can actually have satisfied tenants. Next slide, please. Okay, and then the final link in the chain, concrete as a carbon sink. Next slide, please. So look, most people don't realize concrete will absorb CO2. We conservatively estimate that concrete absorbs about 10% of the CO2 that was initially emitted during the manufacturing and transportation of both cement and concrete. We're very comfortable saying that. We actually think it's a higher number, but until we can actually prove it, we're going to stick with 10%. Again, Don't take my word for it. You can go to the Swedish Environmental Institute, IVL, and Ronnie Anderson is the lead researcher there. Ronnie, Dr. Paul Tennis from PCA, our government affairs team, the US EPA, we all know about this. And this is sound science that we have known about for decades. And in fact, just this past year, actually within the last couple months, IPCC has now recognized that carbonation is permanently sequestering CO2. So doesn't happen overnight. It's a function of the surface area that's exposed to the atmosphere, because you're dealing with what, 400 ppm of CO2 in the atmosphere. And I can send you the links to Ronnie's work, but again, lots of information on this. So keep in mind the 10% number. Next slide, please. Okay, so I said society needs concrete and concrete needs society. So next slide. Here's where society comes in. Look, research. There is no CCUS that has been installed at a cement plant at scale. We need research to show that that can be done. And we need research to show how, where, and how, and most effectively we can do that. Likewise, we need guidance on regulations and permitting. So look, depending on who I talk to in the government, they tell me either CO2 is a waste or CO2 is an emission to be regulated. So it's either a waste to be taxed or an emission to be regulated, depending on who I talk to in the government. We got to get that figured out, and quickly. We need some certainty. Every cement plant in the U.S. follows what they call Title V air permitting. And those are all publicly available. So in terms of compliance and reporting and everything else. Financial incentives. Look, it costs, roughly speaking, more than $1 billion to build a greenfield cement plant. If we're talking about CCUS, we're talking about hundreds of millions of dollars. Wouldn't it be nice if we could figure out a way to incentivize that so that we can get those things built once we do know the technology? So is that a tax incentive? Is it a subsidy? Is it, I don't know, but we should incentivize it. Performance-based material standards. I've already talked about this. Why is it that when you go in and, you want to buy a cupcake, unless you want gluten-free or something like that, but by and large, you know what you like, right? And whether they use 3 tablespoons of sugar or 4.5 tablespoons of sugar, or whether they use stevia or baker's flour or not baker's flour, or the special sugar, whatever. My point is, let's focus on performance, all right? That is a really economical way to reduce carbon. Carbon pricing. People talk about carbon tax. Carbon tax gives you certainty on the price of carbon, but if the carbon tax just ends up going to government coffers, I'm a little leery about that. On the other hand, cap and trade gives you certainty on carbon emissions, and that's fine. So in our roadmap, we're suggesting cap and trade. And in part because we think that's where the states are headed. California with AB 32 kind of led the way on that. Market acceptance. I talked about Portland limestone cements. There are proven solutions out there today that we can get at, and hey, we'd like to. Community acceptance. Folks, if we're going to ship CO2, we're going to need pipelines, like it or not. If we want a hydrogen, economy, we're going to need pipelines. We need the community to realize that. And look, that's part of it. I hear a lot about life cycle based, by green. And my first question is always, well, what do you mean by green? Okay, so go back to that Empire State Building. If green means, if green is just looking at materials, we're missing an opportunity. Green needs to encompass the entire life cycle. So that's cradle-to-cradle life cycle. Low carbon infrastructure, again, I've already talked about it, both the pipeline, the grid, and then finally level playing field. And by the way, this is one of my last slides, so I'm almost done here. Level playing field, look, we are in a global community, okay? So regardless of whether it's cement, concrete, steel, aluminum, or for that matter, financial services or legal services or call centers or whatever, any of those industries can be offshored. They can go north to Canada, they can go south to Mexico. If all we do is shift cement production to another country, we're never going to get to that 1.5 degrees, never. So every single country where I visit, when I talk to my counterparts, we're all on the same page. Don't play a shell game with this. Help us help you reach carbon neutrality. So these are the top 10 policy asks that we've got. And this is where concrete needs society. Okay, next slide, please. All right. And wow, I think I actually may have done that in the allotted time. I'm hoping. All right, so I'm going to turn my screen on, and I'm happy to address any questions. But before I do, I just want to thank Christina and the entire team there, and thank all of you for this wonderful opportunity. Really appreciate it. Questions?
Well, first, Rick, what we usually do is we got lots of folks here, and I'm not sure if we have any questions online. We have about 20 people online as well. So we'll alternate between them. Any questions from the in-person crowd in the back?
Yeah, I just wanted to thank you for keeping your presentation like very at my level. Like, you could have made it way more complicated. It was very understandable for me. My question is, what does captured carbon look like?
Yeah, that's a great question. So if all we're doing is pumping CO2 underground, pumping and dumping, I'm not in favor of that. I think, and look, this is where academia comes in. We've got to transform CO2 into products that aren't, my pet peeve, I hear people saying, and there's an algae project up in Canada where they're taking algae from CO2 from a cement plant, turning it into algae, taking the algae, turning it into biodiesel. That's not a solution, okay? That's not a solution. You've got to take the CO2 and transform it into a product that doesn't end up as CO2 a year later. So I wish I had a better answer, but that's my opinion.
Okay. Any other questions in the room before we go to the, go here?
So my question is about Portland limestone cement. So you mentioned that replacing it with replacing the normal cement with it would reduce the carbon emission by 10%. But does it only include the construction and user phase? For example, if a certain area doesn't have access to Portland limestone cement, they have only access to normal cement, they will need to use transportation to transport that from a different place. And also, like, if they want to modify the normal cement by increasing the limestone percentage, that would also include additional processing. So, like, it depends, right? So
Okay, so I want to make sure I've heard the question correctly, but keep in mind, Portland limestone cement essentially, because every plant is by a limestone quarry. So all they've got to do with that limestone, they're crushing it anyway to use in the cement manufacturing process. So all they have to do is, once it's crushed, divert 10% of it that then gets mixed into the clinker at the end of the process. So they're not using any more energy to produce it. They're not using any more energy to transport it. They're saving because that limestone doesn't go through the process. So that limestone won't be heated up to 2,700 or 2,800 degrees Fahrenheit. So they're saving the CO2 emissions from the combustion, and because they don't have to calcine that limestone, they're saving the chemical fact of life. So that's where the advantages and the benefits come from with Portland limestone cement. And again, we've known about it for a long time, but I got to tell you, this is one of the inertias that we are trying to get across as an industry. It's not us, it's, state DOTs. I mean, right now we still have not quite 40 state Department of Transportations that have approved Portland limestone cements, but it's been an uphill battle. It's, institutional inertia. I hope I answered your question if I understood it correctly.
Yeah.
Okay.
Let me ask a follow-up question to that, because having a lot of discussions with partly driven by cement, with the Natural Resources Defense Council about obstacles to implementation of solutions for cement in terms of reducing, getting to net zero. And one of the things we're talking about is civil engineers are basically trained to avert risk, and there's not that much of a reward system for innovation. And there's a lot of penalty if you do something that isn't standard practice. The legal standard is if you do something that everybody else does, even if you know it's not very good, you're essentially legally covered. Now, I'm exaggerating here a little bit, but could you give some thoughts on what innovation, incentivization in civil engineering, recognizing that our first priority that we're trained for is to protect the public? How would that look? How do we change the legal and the liability structure for that, and the financial structure?
Yeah, and that is a great question, and that's what I call, in deference to James Cameron and Avatar, I call that the Unobanium Paradox. So assume tomorrow you come up with a material called unobtainium. And unobtainium, it's wonderful. It's stronger than anything known to mankind. It's lighter. And by the way, the byproduct of its manufacture is will solve world hunger. Nobody will use that unobtainium. Why? Because number one, it hasn't gone through a voluntary consensus standards process. So ASTM in the United States has standards for everything, including cement and concrete, literally thousands of standards. A standard, the standards process is a little bit like the legislative process. It's very time consuming, it's very adversarial, and there's no incentive to get things done quickly. Well, engineers and architects will not use a product unless it has gone through that process, unless there's a standard or a specification for it. Why? Because the building code authorities won't allow a product unless there's a standard or a specification for it. So one of the things that we could do, and we've been in discussion with ASTM about this, one of the things we could do is to have a process where we could fast track innovative materials. Fast track, by the way, in the standardization process would be like 5 years. And the reason I say that is because, believe it or not, just to get limestone included in the specification for cement, just a small percentage included, that took 25 years. We don't have 25 years. So one of the things we could do is really encourage the standardization bodies along with the code authorities to give us more flexibility when it comes to innovative materials. And by the way, nobody is saying that we don't want to make buildings safe. right? As an engineer, that is our primary duty. But that doesn't mean we can't use materials. Like I said, Portland limestone cements, for goodness sake, it's been around since the 1960s. Slag cement has been around since Paris built their underground in the late 1800s. This is craziness. Anyway,
Thank you.
sorry for the diatribe, but
It's okay.
I'm passionate about that.
I got on my soapbox to get you to get on your soapbox there. So let me, sorry, indulge me here. So how do we encourage, what's the policy lever to encourage ASTM and these other groups, which are not governmental, to go the direction that you're talking about? And who protects, you know, where's the legal liability, which is usually the biggest question, or the fear of legal liability, even if it's not there, is one of the biggest questions. How do we get
Well,
there faster?
So there's two, you're asking, I mean, you've got two parts to that question. So let me address the legal liability. If I design a building and it meets the code, that's the standard of care, right? If it meets the code, that is the standard of care. So really, where we need to focus on is on the standards and the specifications, because that then feeds into the building code. So what we need to do, it's got to be a full frontal assault on ASTM, the governing body, to get them to move forward with these things. Now, to their credit, they're starting to realize that. It's not fast enough for some of us, but I will admit they are starting to realize that because global warming is the issue of the age and will remain the issue of the age until we do something about it, then I think we have a real opportunity to shift that. And I think we can look at that. The other group I wanted to point out is ACI, the American Concrete Institute. They now are looking at a process where they can too accelerate some of their documents that are more responsive. You know, and by the way, keep in mind, all these organizations, they have volunteers. These volunteers meet twice a year. You know what? If you've got an innovative product, meeting twice a year is not going to cut it. You need to meet twice a week. And I think you have some really aggressive, innovative star performers that are willing to do that. We got to let them loose and get out of their way. Sorry, more soapbox.
Maybe we can go to a web question.
So here's one. Okay, this first question was answered, I guess. New question. What would shift the market fastest? A big fee on carbon to account for the climate crisis, externally cost of carbon, so that carbon cement would be much cheaper than old cement very soon? What are the other accelerators of change? And that's in the Q&A.
Wow. Okay, so number one, I don't think there is any one thing that's going to move the market. Now, I think, because I think it's it's a societal issue. So let me give you a couple of examples. We are now seeing, just in the past few months, I'm seeing cement plants that have made plans to no longer produce regular cement. Their entire product line will be Portland limestone cements. Why is that? That's because consumers, their buyers, have demanded that. So that's part of the equation. The other part of the equation is on the legislative side, on the lawmaking side. And there, it's a question of balancing protection for the domestic industry, balancing that with incentivizing. So, and not to get too far into the weeds, but there are things like 45Q, which allows a price of, I think it's $45 for every ton of CO2 captured. It's a good program, but it should be strengthened. It should be amplified. And there are some intricacies with it that unintended just push people away from it. So there's solutions out there. I like to say there's no silver bullet, there's silver buckshot. So the idea that any one thing will move the market, I don't think that's the case. And by the way, when you say the market, you know, you got to look at different market segments. So California has a different concrete market than Montana. Montana has a different cement market than Florida. You know, so you've got to look at all those combined. And I don't know that I can get a better answer to that question. I will say for whoever wrote that question, one of the things I would recommend, there's a think tank in Washington, D.C. that we've gone to a number of times called RFF, Resources for the Future. And they've looked at some of these externalities and looked at the economic side of what would push policies. They're a nonpartisan think tank, widely respected among lawmakers. And they're the ones actually that have looked at things like carbon pricing versus cap and trade. And how do you make these things WTO compliant, which is a whole nother topic. So I haven't answered that, but hopefully that gives you a little bit of direction.
Okay, excellent. In the back, we'll come back here.
Hi, first I'd like to acknowledge your, bravery in coming and representing, I guess an industry that a lot of people, don't have a great view of, and I appreciate that, to come and make this presentation. But the question I have is that, like, the embodied carbon is still, by all accounts, 30% of our built environment's life cycle carbon emissions. So, like, do you foresee like a situation where, for example, in California, our green building codes are pushing buildings to be more efficient from the use side? Do you foresee the building code incorporating embodied carbon in its regulations and, pushing, reduction of the use of concrete and cement?
Okay, so a couple of points. Firstly, I think the energy code, the International Energy Code, goes a long way to addressing the use case. Secondly, that 30% number that you quote, and let's not, whether it's 30% or 3%, the question becomes, why is it 30%? So if it's 30% because that building was only designed to last 20 years, that's problematic. I think that's the kind of approach we need to take. So as an example, when I talk to designers, I tell them, you can't just design this building for its current use. So if you're building a dormitory, think about, okay, 20 years from now, what if I wanted to convert that to an assisted living facility? And how about 40 years from now, what if I wanted to convert that to a distribution center? That's the kind of innovation we ought to be looking at. And I'm not against, believe me, I don't diminish the impact that embodied carbon has on the building materials. But this goes to my point of taking, firstly, a holistic approach, and secondly, being very intentional. I'm dating myself. When I first started as an engineer, you'd go to a job site and people would refer to concrete as mud. When is the mud going to show up? No. We have to view not just concrete, but we have to view all of our building materials as a precious natural resource, artificial resource, but we have to view it as a precious resource, just like that gold foil tape. That's my whole point behind that. I think when you do that, if you start way back in the design phase, and actually even before that, if you start with the owner. So look, and I saw a little bit of soapbox, but as an example, the idea, if you've never heard the term spec building, a spec building is a speculative building. There's no tenants. So you buy a piece of a property developer buys a piece of land and they say, oh, this is a good place for a strip mall. And they build a strip mall. We can't do that. So that's the start of the process. And I think that kind of dovetails. I'm all in favor of lower carbon building materials. We can get there. But again, if I want to go from 30% to 15%, then I need help from the state regulators and the state DOTs to allow me performance-based specifications, to allow me to use Portland limestone cements, to allow me to do innovative material techniques that are out there that currently aren't allowed. They can do that, but you know what? One of the reasons why they don't, look, they have no incentive to. Unfortunately, as you'll find out, when it comes to legislators and lawmakers and lawyers, their incentive is to continue the process. They don't want, unfortunately, the vast majority of them don't want to get to a solution point, because then they think they're out of a job. And for a lawyer, that's the end of their case, the end of their fee. Look, that's not all of them, but this goes to the issue of institutional inertia. Hey, I'm looking at a class full of people that I'm hoping aren't going to have that kind of mindset. Sorry for the rambling, and I probably didn't answer your question, but there you go.
Did you have a follow-up on that, or did that answer the question?
I had a separate question.
Let me come back for a separate one then. Go here. Yeah, sorry.
I have a pretty simple question, but I'm interested to know where is the greatest demand for new cement coming from, and also what is the average turnover of cement in some of the most common applications? Like, how long does it take before
When is the end of life?
yeah. So
Well, the end of life question really depends on the application. So look, I'm not there today, but I live in suburban Chicago. I don't know, 10, 15 years ago, we rebuilt Wacker Drive. It's a double-decker highway in the city of Chicago. Very unique. It's the only street in Chicago that runs both north, south, east, and west, believe it or not. In any event, that concrete was designed for a design life of 100 years. That was a guarantee. And they did an awful lot, the concrete mixer and the contractor did an awful lot of testing to make sure that they could actually meet that criteria. I think they will meet that criteria too, because I've seen the mix design. So it depends on the application. Now, I'll contrast that 100-year highway with like the guy who's building a strip mall. Does he really care if the concrete's going to last 20 years? Not really, because in 6 months after that mall has been developed and after the construction financing has been completed, he or she, they're gone. They're gone. They've already sold it to somebody else. So it really depends on the application. The people that have the highest vested interest are the government, is government, the local municipalities. Why? How many of you like driving on, roads with potholes? Do you know that's probably the #1 call that politicians get? Why is my road falling apart? Why is this bridge falling apart? How come I drove my car underneath and by the way, this concrete just, boom, fell on the hood of my car. So that was the use phase. Well, the first part of the question, John, was what?
where is most of the demand for new concrete coming from?
Do you mean regionally in the world?
No,
or
just
what
like the kind of applications.
Oh, by far government, by far. So in particular, roads, buildings, bridges, tunnels, that's where the vast majority of use of concrete comes from. Percentage-wise, I don't know offhand, I'd have to check. But yeah, by far, it is really the government. And by the way, I should also point out something else real quickly. When you look at the countries, producing and consuming the most cement and therefore the most concrete, why is that? Well, that's because those countries are transitioning from underdeveloped to, from third world countries to, wait a minute, I'm getting that backwards. You get the point. They're transitioning to modern economies, China and India. In the US, we're #4 worldwide for cement production and consumption. Well, why is that? Well, we have a very mature economy. We've built our infrastructure. Yes, it needs to be rebuilt, no question about it. But by and large, we don't have the the interstate highway kind of projects that we had back in the 1950s and 1960s. Those days are long gone.
I'll leave order of.
And we've built our housing stock.
I think order of magnitude, I think Caltrans is on the order of 30% of concrete usage. Department of Water Resources for canals and water delivery is probably up there. And then you start getting into local government. Okay, thank you. Yeah, I'm trying to go in rough order. We'll go left and then right.
My question, and thank you for the presentation. It's an interesting point of view of the cement. My question would be like, where do you think is more likely that some of the standards could be maybe reduced or become more innovative for like different applications of the cement? And in terms of roads, and maybe linking to one of the professor's classes, like the application of a road is not just like only where the cars go, but like maybe, I don't know, sidewalks for bicycles, like maybe in those where the need of maybe less rigid concrete could be a better way to start there and reduce maybe some of the standards there, and maybe that's where we could start from some innovation.
Adjust the standards for the functionality, not reduce the standards.
Yeah, adjust the standards for the functionality.
That's, well, when you say adjust the standards for the functionality, that really gets right to my point about switching from prescriptive to performance specifications. Functionality, that's what performance is. So look, you know, your example about a road needs a certain amount of strength because it's going to carry truck traffic, right? On the other hand, a sidewalk or a bike lane, they don't need that kind of strength. On the other hand, they probably need better durability. Maybe they need more skid resistance. So yes, that ties exactly into this idea of going to performance-based specifications. And your point about functionality is spot on.
Well, we've done surveys and found higher carbon content by 40%, 20% in a local government sidewalk mix design compared to a Caltrans highway design. And part of that is the diffuse nature of all these standards. There's 482 cities in this state, and they're all responsible for their own specifications. And so part of this is just the diffuse nature, particularly in a local government, but then 50 states as well. So this is kind of an organizational, human, how do we make things go faster kind of an issue. Question.
This is more of a construction question, but are there any concerns about increasing weather volatility, like just with daily temperature ranges?
Climate resilience.
Will impact.
Oh yeah.
It will, sorry, I'm not, but impacting like the curing of the concrete and the long-term performance, just in certain regions of the world.
So there's a couple parts to this. Firstly, concrete structures are very resilient, right? And if you, provided you build it correctly, the climate change does not impact a concrete building nearly as much as it would, for example, a brick building or some other structure. Concrete is also, I think, a real viable solution for some of the extreme weather events. So if you think about it, you know, we have, and John could talk about, you know, some overtopping protection that we use with things like roller compacted concrete and other applications. So concrete can be part of the solution. If your question is, hey, are these extreme weather events going to damage concrete? Are they going to impact their long-term performance? Generally speaking, I would say no, they are not. I think in fact, that's their biggest benefit. So you have concrete structures, and I can show you pictures of, you know, aftermath of Hurricane Andrew or aftermath of wildfires. The only building left standing, and by the way, these are residential buildings. The only building left standing is a concrete building. And these have been showcased in, you know, news media like CNN and other places where you've got one building And for miles around the entire beach, there's nothing left. You know, when we build, and you think about hurricane control, all these hurricanes in particular, when they rebuild, FEMA rebuilds not to a higher standard. By law, they have to rebuild to the standard that the building was at originally. So if that's a building, a house that has 2x4s, guess what? That's what they rebuild. A 2x4 house is not going to withstand a tornado or a forest fire or a tidal wave or a seiche or, you know, fill in the blank, or a hurricane or high winds. They can't. They're just, I'm sorry, that they just lose out when it comes to that.
One thing we are worried about is drought and drying shrinkage, so, in California.
Yeah.
Web question?
Aditya, looked like you had a
Sure.
question.
Yeah, couple of points. I actually wanted to also point out that, I mean, to the point that you made on housing, I mean, I think the US uses a lot more wood just by practice.
Yeah.
And therefore, countries like India, I mean, I wouldn't want to call them third world, and I would strongly not want to call them third world. Also, but, you know, we've historically had a practice of using concrete in that part of the world for housing, which is why our demand and cost for concrete are far, far lower than the US. But anyway, my question was slightly different. My question was actually on SB 596. My understanding is that the cement industry was the one that actually asked for SB 596, or at least was the one that initiated the process. It was interesting, but I wanted to understand if what was the trigger or the market risks that the industry saw that you felt that you wanted to self-regulate and kind of probably, I guess, get ahead of the curve. And while you have a roadmap, how much money is the cement industry actually committing to kind of abating emission reduction? And do you think that that would have a negative impact on cement prices in the medium term?
Okay, well, I can't talk about cement prices because that's an antitrust issue. The point about the Senate bill, let me address that first. You know, and by the way, your point about India, I is well taken. I don't mean to suggest that India or China is undeveloped. My only point is that they continue to develop at a very rapid pace. The reason why the cement industry is so, you know, aggressive about carbon, guess what, folks? I may be older, but I have the same concerns you do. Everybody in our industry has the same concerns. We are not, it's not a us and them situation. We've realized this, and we also realize we have a great opportunity between the change in administration and society at large finally realizes we got to do something. We've known about this problem for decades. And look, I've been in the cement industry nearly 30 years. So this is nothing new. What is new is that we finally have an opportunity where we can sit down collaboratively with stakeholders. And by the way, that includes the legislators. So they're asking us, because California doesn't want to see cement plants shut down here just to open up, you know, in China. And they don't want to import Chinese cement or Mexican cement or wherever. That doesn't, again, that doesn't get you to 1.5 degrees. We all know that, right? So the idea is that we are sitting down proactively with states, state legislators, and also on Capitol Hill. And we're saying, help us help you. So when I showed that top 10 priority list, that the policies, those are some of the things that we've been talking to them about for a while and saying, look, here's easy things you can do. Here's, you know, incremental steps you can do. I keep going back to Portland limestones because that's such a ridiculously and absurdly easy thing for them to do. So that was the point about SB. And, you know, again, and by the way, all of our emissions, they're governed by law. We have to monitor, we have to comply. People go to jail for not doing that kind of stuff. Our industry is relatively young in terms of the personnel. So, you know, they, look, I mean, nobody wants to work at a plant that, you know, is a filthy plant. they have a family, right? They have the same environmental concerns, the same sustainability concerns that you guys have. I don't think it's, different. It really is not. What is different is that we're trying to do something about it. We're, I think, the only US industry today that has made that kind of commitment. I don't see petroleum doing that. I don't see, anyway, again, no soapbox, I'll stop there. And then the pricing, like I said, I can't answer that because that's antitrust.
That actually is a legal requirement when you work for it. But I have two questions, follow-up questions. We've been talking with other folks, partners around the world. Preferred term, what would you term an economy that's building out its infrastructure versus one that built it out earlier?
Well, I think we've now moved to an established term of emerging market economy.
Okay, good.
Yeah.
Thank you. Thanks for pointing order on that. I can mention a little bit what Rick can't about price. That's one of the concerns, particularly because in many of the countries that are emerging, the housing market, which affects everybody, particularly the poorest, who have the biggest issues with housing, they're dependent on concrete and cement. So the worry is, how do you build market structures that don't just layer on price, because that's actually regressive in terms of the cost impact. So that's one of the biggest issues worldwide. Not as much in the United States, because we actually use aluminum now. If you look at student housing over here, depending on the price, but particularly in the emerging world, the price of cement is make or break in terms of the ability for housing for the masses.
Hey, and by the way, John, could I also mention too, one of the other things that would really help, especially with China and India, most of their product is sold in a bagged format. That's inherently inefficient. So as they continue to emerge, transition from emerging economy to more industrialized in some regions, I think you'll see that change too.
We're about at time. Let me take one more here, and then we'll see if we have one more on the way, and then we'll wrap it up. What was the question here? Right here. Okay.
Is treating carbon or treating concrete as a carbon sink, is that going to be at odds with getting more permeable concretes that let water percolate the aquifer stuff? Did you hear her?
Yeah, I did. So no, it is not. So there's apples and oranges here. So all concrete absorbs CO2, all concrete. And it's a long-term process. Again, it takes decades. Now, if you want concrete to be permeable, there is a thing called Pervious Concrete. And that allows water to directly percolate into the soil. And that's used, obviously to reduce impervious areas. So that's two different things. But all concrete will absorb CO2.
The Pervious Concrete uses the same cement, and it works fine. We have a last web question, and then we'll wrap it up.
We do have one more web question. In a future where we make products out of CO2, creating a high demand for CO2 as a commodity, how do we make sure we're adding demand for the right CO2 direct air capture and not promoting other cheaper sources of CO2 direct burning or fuels?
Boy, and listen, this goes, I'll tell you, this is the question of the age. Global warming is the symptom, but the real problem in my mind, the root problem that has to be addressed is energy. Where does the energy come from? So if you think about direct air capture is a just enormous amount of energy to make that work. And I think I don't have an answer for that, because trust me, if I did, I'd be richer than Elon Musk again. And trust me, I'd be off planet by now. But I think that's really the question. Those two questions are so interlinked. How do you reduce the CO2 footprint? Yeah, that's a technology question by and large. But where do you get the energy to do that? And that's a societal question. And that's a question that everybody in that room is going to have to answer. I don't have an answer for that. I'm sorry. You guys do. I'm sure you guys do.
On that note, thank you, Rick. Rick, we had a question about whether the presentation, not just recording, but is the presentation accessible somewhere?
Yeah, I'll be happy to put it into a PDF format to reduce the file size.
Okay.
And listen, before I go, I just want to say again, thank you to Christina and thank you to Professor Harvey. Look, I really enjoyed this. And if you do have any follow-up questions, please, I'm a phone call, email, text away. Happy to address it, okay?
All right, thank you, great question.